In this first sublesson, we'll look at the basics of BGP sessions. We'll then configure a simple EBGP session, and then we'll secure the BGP session. Now, you learned in the previous lesson that BGP views its neighbors differently than IGPs do. BGP is designed to run between untrusted peers. Its sessions are point-to-point so that the conversations with those untrusted peers can be carefully controlled. The implication of this is that BGP sessions are always unicast. That is, unicast IP addresses are the endpoints of each session. Each BGP session must be explicitly configured for each BGP neighbor, specifying the unicast address of that neighbor. This is in contrast to IGPs, which are enabled on an interface and which use broadcast or multicast addresses so that they can easily discover and communicate with any neighbor sharing a subnet with that IGP-enabled interface. BGP runs over TCP, a point-to-point protocol. Specifically, BGP uses TCP port 179. This is again in contrast to IGPs, which run either natively at layer 3 or which, for example, in the case of RIP, uses UDP. The use of TCP allows at least some simplification of BGP. Rather than implementing its own session reliability mechanisms, BGP uses the acknowledgement, retransmission, and sequencing mechanisms of TCP. EBGP means external BGP. That is, it runs between neighbors in different autonomous systems. This is the most basic form of BGP as you understood it from Lesson 1. There's another form of BGP, internal BGP, or IBGP, which runs between neighbors in the same AS. We'll talk about IBGP in Lesson 3. There's two simple steps for configuring EBGP. First, we have to start the BGP process and specify the router's local autonomous system number. We do that with the router BGP command. And again, that autonomous system number specified here is the router's local AS number. Then we have to specify the neighbor's unicast address and its AS number. We do that with the neighbor remote AS command. Here's the network that we'll use for our configuration example. There's two routers that I've pretty unimaginatively named R1 and R2. They're connected by a single link, and the interface IP addresses are 192.168.1.1 and 192.168.1.2. And we can see that R1 is in Autonomous System 65501. R2 is in AS 64950. So they're in different autonomous systems, and so we know that this is going to be an external or EBGP session. Recall from the first lesson that these are private AS numbers, just as the IP addresses used in this example are private IPv4 addresses. That's just for this example. BGP can use any combination of public and private AS numbers and public and private IP addresses. Also note that the routers in our example would certainly be a part of a much larger network. There would likely be many routers in each AS, and the two ASs themselves might be part of an extensive inter-AS network, like the Internet. Well, we don't really care about all that for our example. We only care about the BGP session between just these two routers, so that's all that's shown. There are a couple of assumptions to keep in mind as we go through this example. First, there's an assumption that the interface addresses have already been configured, which they have, and that they're on the same subnet. I used a 30-bit address mask for the two addresses in this example, and that layer 3 communication between the routers has been verified, for example, with a ping between the two addresses. Second, BGP assumes that the neighbors you configure are directly connected on a shared subnet. This is default EBGP behavior. That default can be changed with something called multi-hop EBGP, which is discussed in Lesson 4. Okay, so we've got our two terminal screens up for R1 and R2. Let's start with R1. So we'll go into configuration mode, and we're going to start the BGP session with router BGP, and our local autonomous system number is 65501. Now we want to specify, and you can see that we're in router config mode, we're going to specify our neighbor connection to R2. So neighbor, the address over there is 192.168.1.2, and the remote autonomous system number is 64950. And that's all we need. Now let's go over to R2. Again, we go into config mode, and we start the BGP session. And in this particular case, our local AS number is 64950. And our neighbor is going to be R1, so 192.168.1.1, and the remote autonomous system number is 65501. And that's all we need. And with just a moment's wait, you'll see a message come up showing the BGP session starting. And there we go. You can see a BGP adjacency change for neighbor 192.168.1.2, and it's up. And over on this side, we get the same thing for neighbor 192.168.1.1, and we show that that's up. As you certainly know, any protocol session should be secured with, at a minimum, some sort of authentication between neighbors. Session security is especially important for EBGP because, as I've repeatedly emphasized, EBGP runs between untrusted peers. And because EBGP is the public-facing routing protocol for most autonomous systems, it's the routing protocol most readily accessible to attackers. Far more attacks are directed against EBGP than any other routing protocol. BGP uses MD5 authentication, and while it's usually good enough to use a common password within an AS for all IGP sessions, and even for IBGP sessions, you should use a separate password for every EBGP session. This is again because each session should be considered unique and established to an individual, untrusted neighbor. An argument can be made, I suppose, that multiple EBGP sessions to neighbors in the same AS can use the same password. Well, that's up to you. But never use the same password for neighbors in different autonomous systems. MD5 authentication is configured for a neighbor with the neighbor password statement. So let's secure the sessions that we configured in the last example. Okay, so let's secure the sessions that we configured in the last example. We'll start here at router 1. So go into configuration mode, and we get back to our BGP configuration. And we specify neighbor 192.168.1.2 password, and let's make up something. Let's say I love BGP. It is case sensitive, and hopefully you're using a better password than what I just made up right there. So that's it, and it's secured. Now we're going to go over here to R2, but before we do that, notice what's all of a sudden happening. We're getting these bad authorization messages that says no MD5 digest from 192.168.1.2 over here. So what's happening there is I've configured R1 with a password, but I've not yet configured R2 with that password. So now the session is down because our security isn't working. So going over here to R2 and going into router BGP 64950, and I say neighbor 192.168.1.1, password I love BGP. Hopefully I remembered to spell that correctly. And we go out of that. And if you look really closely over here, an interesting thing is happening. The session is still not back up. And in fact, what you'll see incrementing every now and then are still these bad authorization messages over here at R1. The reason for that is because we made this configuration change, we actually have to reset the session. And see, there's an example of that bad authorization message still coming up. We have to reset our BGP session. And we do that with a command called clear IPBGP, and we're just going to use an asterisk, which means clear all BGP sessions. And when I do that, you'll see the session go down here, and then in a moment you'll see the session come back up. And there it's come back up on both sides. So one of the things to be aware of is that there's a lot of BGP configuration changes that require you to clear the session. And we'll talk a lot more about this in lesson 15, where we do resets, and we can do less disruptive clearing with things called soft reconfiguration, and the latest version of that is route refresh. But it's important to see that in the beginning.